Hey everyone, I am Vaishali. In previous lectures, we have already started the chapter number 6 of 11th physics, which is mechanical properties of solid. And we already studied about elasticity, plasticity, and what is strain, what is stress. Its different types, means three types according to length, volume, and shape. Now in this lecture, we are going to learn about different modulus of elasticity, which are also depending on these three types of stress or strain. Means according to length there is different length or longitudinal stress and strain, there is different modulus of elasticity. Then according to volume there is next modulus of elasticity, and according to shape or shear there is different modulus of elasticity. That means there are also three types of modulus of elasticity. Before going to learn about modulus of elasticity, we are going to learn the Hooke's law. What is Hooke's law? So let's start with the definition of Hooke's law. Then what is Hooke's law? In previous lectures we see the diagram of rod and rod of length L, and we attach the force or weight to the rod. And if we increase the load of the rod, then what happens? Its length gets increases according to weight or force. And if we are going to increasing force more and more and more, then what happens? After some time or after some limits, it gets permanently changed in its shape and size. That means there is limit to which we can increase its stress, and within that limit, stress is directly proportional to strain. And after that, stress and stress are non-linear. Means within this limit, graph of stress and strain is straight line, and after that limit of elasticity it gets curved shape. That means let's start with the definition of Hooke's law. What is Hooke's law? It states that within elastic limit the stress is directly proportional to strain. That means there is limit to how we increase the force, and after that force it gets stretched. So Hooke's law is it states that within elastic limit stress is directly proportional to strain, and its mathematical statement is stress is directly proportional to strain. And if we remove the proportionality constant, and here m is proportionality constant, capital M, therefore stress is equal to m into strain, where m is modulus of elasticity and m is equal to stress upon strain, where m is modulus of elasticity, and its unit is also like a stress, because stress divided by strain, and strain is unitless and dimensionless quantity. Hence its unit is of the stress unit, and which is Newton per meter square or Pascal. So according to different types of stress and strain, modulus of elasticity also have three types according to length, volume, and shape. So let's start the types of modulus of elasticity. So first type is types of modulus of elasticity or elastic modulus, which is denoted by M. Then first type is Young's modulus, which is denoted by capital Y. Then what is Young's modulus? It is a ratio. It is simple ratio of stress to strain. Longitudinal means Young's modulus means it is ratio of tensile or longitudinal stress to tensile or longitudinal strain. That means here length is included. Stress with respect to length divided by stress with respect to strain with respect to length. That is Young's modulus Y is equal to its definition is it is ratio of tensile stress or longitudinal stress to tensile strain or longitudinal strain, and its mathematical formula is Y is equal to longitudinal stress upon longitudinal strain. Therefore, y is equal to, what is longitudinal stress? We know that in previous lecture, longitudinal stress means force upon area divided by longitudinal strain means change in length upon original length. Therefore, y is equal to, here a is denominator of numerator, hence it is going to numerator of denominator and n in upward side. Therefore, y is equal to f into L divided by a into delta L is the Young's modulus, or y is equal to, f means force, force or weight, which we attach to the wire, and weight means m into g. Therefore, mgl divided by a means area of cross section of wire, which is pi r square. Therefore, its formula is y is equal to mgl divided by pi r square into delta L, and its SI unit is Newton per meter square or Pascal. Here you may have noticed that all the units of every modulus or every type of strain is Newton per meter square, and all the units of stress and modulus of elasticity is Newton per meter square or Pascal, and every strain means three types of strain both everyone is unitless quantity. Similarly, next type is related to volume, and which is known as bulk modulus. Second type of modulus of elasticity is bulk modulus, which is denoted by capital K, and its definition is it is related to volume, means volume stress to volume strain, its ratio. Therefore, let's see its definition. Bulk modulus K, it is ratio of volume stress to volume strain. Therefore, K is equal to, its mathematical formula is volume stress upon volume strain. We know that volume stress means dP, change in pressure we apply on volume, and divided by volume strain means dV by V, which is that means change in volume divided by original volume, and we take the negative sign because as we apply pressure its volume gets decreases, hence we indicate it by negative sign. Therefore, K is equal to, V is denominator, hence it is going above side. Therefore, K is equal to minus V dP by dV. And in magnitude we didn't need to take its negative sign, hence K is equal to V into dP by dV, and its SI unit is, as already we see, every modulus has unit of stress only. Therefore, its SI unit is Newton per meter square or Pascal. And similarly, the next definition or next concept is compressibility. Compressibility, which is denoted by capital C. Compressibility is simply the inverse of bulk modulus, that is 1 upon K. It is the reciprocal of bulk modulus. Hence, its definition or mathematical formula is C is equal to 1 upon K. Therefore, C is equal to 1 upon K is equal to V into dP by dV. V into dV by dP. This is get inverted, and its SI unit is opposite to this. Opposite to bulk modulus or stress, and which is meter square per Newton. Meter square per Newton or per raised to minus 1 or per pa. So this is bulk modulus. And the last type of modulus of elasticity is modulus of rigidity or shear modulus, which is denoted by eta. This is eta, like N, eta symbol. Now Its definition: modulus of rigidity or shear modulus eta. It is the ratio of shearing stress to shearing strain. So let's see its definition. It is the ratio of shear stress to shear strain. Therefore, eta is equal to shear stress upon shear strain. And you know the mathematical formula of shear stress and shear strain. Therefore, eta is equal to shear stress means force upon area divided by shear stress means theta. Therefore, F upon A upon theta divided by theta. Therefore, it becomes theta is equal to F divided by A into theta, where F means tangential force applied to the body, and its SI unit also Newton per meter square or Pascal. So this is everything for today. See you in the next video. Till then, bye bye.